Hello and welcome back. This is a supplemental recording. What I mean by supplemental is it's just outside of my standard recorded time. The reason why I have decided to do it today is just trying to get some motivation to keep working on it, and to go over some of the things that I've learned over the last couple of days that probably don't fit directly into the AI movement. So we'll get started right away. We're going to talk primarily about Bevy and Godot today, and kind of the connection between them, and we're going to demonstrate a system which takes advantage of the Godot scene tree within Bevy. So without much further ado, let's go into our programming view here. And that should be big enough. Let me maybe make it one more bigger. Yeah, there we go. That is pretty big, but that should be helpful. Let's move this. Don't need that big. Okay. So what I have done, and in all reality, I looked at some ways of accomplishing the goal that I had to see how I could do it. And we've put comments on here to help you understand what's going on. So the idea here is I was kind of playing around with goal-oriented movement and trying to figure out, okay, well, how am I going to do this? The first problem that I had to kind of overcome was the representation of a game world, in trying to figure out if I needed a representation of the game world in both systems, in Bevy and Godot. So for example, if I go to Godot and show you kind of what I'm talking about, let's go to Godot. You can see like we have a tiled game map that might look something along those lines. And we have our tile map nodes, sorry, our tile map layer nodes that each have individuals. And the idea is that all of our all of our individuals would, move around on this map, that they would interact on this map, and that any movement would take a place in this map. So the first big hurdle to overcome when dealing with Bevy and Godot is, okay, well, if Bevy, or sorry, if Godot is my presentation layer, what am I doing in Bevy with regards to world map? And that's kind of a loaded question because it does depend on it does on your need for physics, right? If you are dealing with physics that need to be really, really tight, like let's do like a 2D platformer, or something along those lines, then you ooh, that's a hard question because I've never dealt with the Bevy Godot in that concept. If you go to their website, though, if we go look at their website really quick. Let me go look at the Godot Bevy, and we go to let's go to the repository really quick because that'll take us to the book. Oh wait, no, it's right there. So if we get into here and we go into sync modes and um, we talk about what we need, they they reference turning off the sync mode, and the fact that where platforms where you need really tight physics, you have the physics happening in Bevy, or sorry, in Godot, because you need to figure that out. Now, this one's a hard one because if you're doing it at that, if you're doing a 2D platformer, I honestly don't see the need for Bevy in that particular situation. Yes, it might help you. It's a fun paradigm to program in, but I don't think you're gaining anything, you know, really, other than getting to use Rust, by using Bevy and Godot. I would almost stick entirely within Godot. So my 2 cents there. Take it with a grain of salt. So back to Godot again. This is our map. So the question for my particular game, the simulation that's not necessarily physics heavy, is where do I represent this map? How does Bevy know about this map if it doesn't exist? And I was trying a lot of different things. So I was using the tiled map editor at first. If you're not familiar with tiled, it is a map editor that it's a really cool editor. You can export it to different game engines. You can add different layers and different objects. It's really neat. It does a lot of really cool stuff. Um, and so my original thought was, okay, well, I can build something in tiled, import it both in Bevy and in Godot. Godot just as a visual representation, and Bevy holds it in its own memory and interacts with it there. And by doing so, like I have a representation in both systems. The source of truth is obviously Bevy's, but then I can just propagate, the visuals up into the actual map. The problem I ran into almost immediately was asset management. If you're doing the Bevy Godot way, working with assets in the PCK file, the pack file, working with assets in general is kind of a pain. And I had nothing but problems trying to use the Bevy ECS tiled crate, and then I went to the normal tiled crate and did kind of like Godot bindings directly. It was getting fragile. I literally had to read from the file system without using like Godot's assets, and so I would have had to ship a non-pack file, and it was becoming such a pain in the butt. Um, and so I decided to approach this a little bit differently. And I decided, okay, well, since my game is not a crazy platformer, I don't need to necessarily turn off transformation sync and do it all within in Godot and then just like very rarely update it. I could do that if we're running into performance issues. I don't think we're going to run into the performance issues with the visuals that we have. So what I decided to do instead was, well, let's manage the entire map in Godot. Let's manage everything in Godot from like the actual layers, and then when we let's is it the ground that I have it on? Let me double check. Sorry. Yes, I have a navigation layer, and let's talk. Let's build the tile map layers that I need in Godot. Let's use Godot's really good UI tooling for painting tiles, for doing auto painting, for adding properties to tiles. So I can go into the actual properties in the tile map itself or in the tile set and paint a particular property on there. You can add your own custom data to individual tiles. What's really important is that I can paint navigation layers onto tiles, right? So if I paint, I can paint all these tiles with a navigation layer, which then I can use for pathfinding. We'll talk about that in just a minute. But the idea here again is that I would do all this work in Godot as the presentation layer and the representation layer. And the reason why I was so hesitant to do that at first is because had kind of I was hesitant to access Godot assets directly that had already been spawned by Godot through Bevy's UI. Um, for some performance concerns for one, and then if you're accessing the Godot world, you're accessing the main thread. And so I have to be very careful with, okay, what do I do on the main thread and what do I not do on the main thread? Because you don't want to hold up rendering on the main thread for like simulation aspects. Excuse me. So with that in mind, I decided to do kind of a little prototype to prove out whether or not I could do this. We'll just build it really quick. We'll see if you can even see. I don't think you're going to see the window, but I can probably show you the debugger. Yeah, let's. Why is this? Okay, I need to make this window just a little bit smaller. Give me just a second. There we go. So you can kind of see it here. Let me pull it up a little bit. Um, but you can see that I have some information about the block tiles, and this is being output by the Bevy side, by Rust's side. Um, and I have a little player that's actually being moved around in there. We'll talk about that in just a second. But the idea is that the Bevy, the Rust side of things, um, reaches into Godot and reads this information in order to make decisions for other aspects of the game engine. In particular, if we're talking about, uh, I called it traversal. It's typically called pathfinding. I should probably rename it to pathfinding. In fact, let me do that right now. Uh, so we'll rename this whole thing to pathfinding. Of course, now everything is broken. Um, okay. And I just realized that you are not in my in my editor. Okay, so I called it traversal, but it's typically called pathfinding. And pathfinding typically relies on something called navigation layers or navigation mesh. In 3D games, it's a mesh that you can overlay on your map, and in 2D games, it's navigation layers that you paint onto particular tiles, and sometimes depending on shapes. And what those layers do is they can inform either you, the player character, that's, your movement system, or typically for AI and NPCs movement systems, to inform them what tiles are able to be moved on. Because there might be tiles that technically don't have any physics colliders, but NPCs should not move on anyways. Like, let's say there's a lava tile. Technically, there's no physics collider there because a player can walk into it and burn up and die. But we also don't want an NPC to move in there. So we can't easily say, hey, don't move into tiles that have physics colliders. We do have to specifically map what tiles the NPCs are allowed to walk on. So let's jump into the code really quick. We're going to go over this, and we'll call this one a day in just a second. I don't know why this is throwing such a fit about components. Mod components. Yeah, I think it's just... Okay, no, I don't want to do that. Okay, so what I've done here is I've created a pathfinding module. And the way I have laid out my modules is to lay them out just exactly like the entity component system is. So if you open up my AI module, I have components. If you open up my NPC, I have AI. I actually have to rename that one. Utils, that one's a little bit different. And world, that one doesn't have anything. So basically what I'm trying to do is any components would be in the components file in this individual module, any systems, and then anything related to another one. So like NPC would have AI. This is any functions related or importing the module AI, right? So the pathfinding module and pathfinding system, at least this demo system, is just to show you how Bevy communicates to Godot and how I would handle things. So the first thing to understand is that we have in our system right now, and I would do this, I'm doing this differently, and I'll explain it differently tonight. We have a simple location component that can be attached to any entity, and that just gives their location in the physical world. I need to change this from I32 to something else. The reason I had it as an integer and not a float is because in a hash map, you can use a tuple of integers as a key, but you can't use a tuple of floats as a key. And the reason why, let's change this really quick and watch what happens, is because the equality trait is not implemented with floats, right? And there's a reason for that. We're not going to dive into here, but just suffice it to say, I can't do that. And the reason I wanted them as integers is so that I could do this hash map of locations that the NPC has typically been to. But I'm actually changing how this works anyways. We actually don't need scene locations. We just need previous location and target, and now we actually don't even need previous location anymore because I'll talk to you about why that is. So now we should be able to change these to float 32s, and we need to get rid of the equality. We don't need that anymore. Um, actually, no. Now that I think about it, we have to have equality on there if we were going to do that. Oh, well, color me surprised. I guess you can use float 32s as a key in a tuple of the hash map. I was wrong. I guess it was the equality trait that was being implemented that was throwing the whole thing off. Anyways, so let's not worry too much about that. Let's go back into systems really quick. Do deck 32. We need to change this back to integers anyways because my original system was integers. Oh my god. Let me just really quickly do. Okay, there we go. That should come back once that is. Let's change this back to integers. There we go. Now systems is working. Okay, sorry, that was way out there. Okay, so the idea here, and I'm going to be redoing how I do goal oriented action in just a minute, is that we in when we are doing any kind of movement that's goal oriented, when we are trying to figure out where a legal move is for an NPC, that's where they can go in this map. Like, okay, if the NPC is starting in this little square here, what squares are legal squares within their, within their uh, axis of movement that they can move to within their speed, within, and the delta of the last fixed update. So there's a lot that goes on here. Um, right now, it's very simple. We're just doing one moves. Like, so within this character, what's a legal move? Okay, what's the destination we're trying to get? Okay, we want to move to this square. What's a legal move? What's the destination? Oh, we're moving to this square. What's the legal move? What's the destination? We can't move to this square. There's no navigation layer. There's a navigation layer here, and both kind of lead toward our goal. So we'll pick one at random. We'll kind of go until we can't get there. And that's a really dumb, like really unintelligent pathfinding system, but it eventually it'll figure something out. And this is where like the scene locations was coming in handy, as in like, okay, we've gone down this route, we've seen these locations, can we find something else? But I have never programmed a pathfinding system before, so this is my first iteration. There are different ways to do this using algorithms, and it depends on how much knowledge you want to give the entity of your space. So a lot of pathfinding algorithms will feed the target or the current location, the destination node, and then they'll use like they'll use various algorithms to plot a course on all the navigation nodes to figure out, okay, how do I get from point A to point B? And it depends on how you want to do this. For the purposes of this demonstration and how I'm doing it almost like how a real person would move. But kind of. It's for demonstration. It's a I can see right in front of me. Let's see, let's move towards my goal, but I don't know, like I don't have sure knowledge of exactly what path is there. And what happens if I sit here, I want to get here, and there's technically no path, and the pathfinding algorithm gives me something that says, hey, there's no path from here to there. What does the character do? The character can't have that prescient knowledge sometimes of like, oh, hey, I can't actually get to this point, so I'm just going to sit here and say I can't get there. So there's a whole bunch of complexity that comes into pathfinding with regards to, okay, how do I make sure that this character is not acting like an all-seeing god with regards to moving from point A to point B? Okay, back to programming because I'm kind of getting into what I wanted to go over tonight, not necessarily what I wanted to handle this morning. And what I want to handle this morning is, okay, we need to, from Bevy, talk to Godot, and we need to get information about things in the Godot scene. Okay. Do. Let me make sure that I am in the right place here. Um, okay, so I really have one system, and these are helper functions for that one system. The one system I have is called goal oriented movement for right now, and again, this is a very simple one. But you can see that this function, there is in Godot Bevy a new system parameter. So system parameters are parameters that you can include in your function, and they have to be in a certain order, um, so that your function signature matches something that the app ad systems can work with, right? And can recognize and then utilize in its special way. So in this particular case, we're using the query system param, and I've got to figure out how to stop uh, VS Code from popping that up every 2 seconds. So we're using the query system parameter, and the query is how you. It's a query layer. It's how you query your component system and entity system to retrieve an iterable. So this is an iterable. This query result is typically an iterable. Um, with these items in there. So you're basically saying, hey, um, I want you to, for each item in this, sorry, I want you to make a query. Find me all entities, and I want to actually return the entity so I know its ID. I want to return all entities that have the move action component and the location component. And this is basically saying that it's mutable. We're going to change the location. We don't need to change move action, but we're going to change location. So I just need all entities with these two components on it, right? But the second system parameter is the most important for our demonstration. It's this scene tree ref. What the scene tree ref is as you can see, let's navigate over it. Um, this comes from Godot Bevy. And what this is it's the scene tree. It is the literal scene tree being returned from Godot for the currently running scene that you are working with. So what we're doing is once we have that scene, we can start working with it. And if we dig into what that scene tree ref is, you can see, we're gonna have to go way in here. Do, 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 do. It's actually, I think it's gonna be better for us to not do this one and instead go into the web really quick so that I can show you what the scene tree ref is. There we go, scene tree. So the scene tree and the scene tree ref is a read on, or sorry, is a do do do. It is not a. If I'm not mistaken, I think it's a read-only reference. Oops. Yeah. So this is the scene tree source. This is the scene tree ref. Let's look at this. If I'm not mistaken, this is uh, a read-only reference to the scene tree. Now you can get the scene tree, right? And then you can start manipulating the scene tree, but you don't have to set it as mutable when it first comes out. What I'm saying is it's immutable until you start iterate or start interacting with the actual scene tree. So for example, if you look at all these methods on the Godot scene tree, you get all the information, right? That are all the different things that you can do with it. And one of the first things that we call on this is we try to get the root node. So if we look at get root, what it returns is is that what I wanted? GD window. Is this even what I'm looking for? Should be. No, that's the oh, sorry, that's the root node because the root node is technically a window. No, that's great. Um, yeah, and if I look at the code, it's the same thing. So the get root node returns a window node, and if we look at the window node and we look further in there, um, we can actually change its class. Right now, it comes into its normal class, and we're going to upcast it to a node. So let's actually look at that really quick. So we get the root node, or sorry, we get the scene tree ref. We use it to get the actual scene tree because we have a reference which is cheap to mess around with, but we need the scene tree now because we're gonna modify it. We get the root node, which if you notice comes out as a window node, but we don't want to interact with it as a window node, right? We need to get an actual node. Um, and the reason for that is very simple. Because the window node inherits from uh, inherits from the node class. In Rust, we're representing that as kind of as a we're representing it as a trait, right? And so it inherits from node. One sec, let me get into node. Let me show you what that is. So the node, the node is kind of like the base Godot object of everything. And so what we're doing with upcasting is it's just a way to convert the smart pointer into the actual class because all the thing you get first is just a pointer to the class. So now we want the concrete class, the concrete node, because we're going to have to iterate on it. And if you notice, we have a bunch more methods on this. We have find child, which returns a potential node. We have find children, which returns node. Get child, get children. And then we have so much more that we can do with it um, that we can mess with. So let's go back into programming, knowing now that we're messing with the root node. I made a utility function that just basically takes that root node. Tilemap layer is the actual node type that we're looking for. So if we go back into Godot, these nodes, these ones that we need to start checking to see if they have navigation meshes, because that's what we're doing. We're trying to see, okay, from a given point, do any of the tile map layers that exist have a navigation layer on them that indicates that we can move to them? And these are all tile map layer nodes, right? Tile map layer, tile map layer. Okay. So we've made a simple utility function called collect tile map nodes. It takes a root node and it has to be the node type. And then it's really simple. We basically iterate through if this is if the current node in this collect tile map layer is a tile map layer, then we want to return it as a layer to put, or sorry, we want to push that layer into this array of tile map layers. We're just basically building a massive array of all the tile map layer nodes within this scene, and we're doing it recursively. And what recursively means is that we are calling this function, or sorry, this function is calling itself repeatedly in a loop until it returns. And so what happens is when we feed it a root node that's a node type, if it's not a tile map layer node, then it will get all the children of that node and iterate through it and call this same function. And so what happens is it kind of trees out and spreads out and finds all the tile map layers. And then as it hits the bottom, it'll start to return and return up and return up. And eventually it'll all return into this, all while adding layers to this reference to a vec, we'll call it an array for ease of use here. To an array, we're going to call them vecs as well. An array of those tile map layers, and these are references. This is a reference to the layer, okay? And what we're returning is references to those layers. So just keep that in mind. So now we call this recursive function. we say, hey, I need all the nodes that are tile map layers in this scene that I could potentially work on. Now we can make this more complex. We probably only want to do it on visible tile map layers. We could make this even more efficient by saying, "Hey, only get the named layers if we're gonna be there." Right now, we're just doing it very inefficiently, and we're doing it very rough to show you how this works. And then quick error out: if there's no tile map layers, well, there's nothing in the scene. Anyways, we're gonna say that we have these potential moves, and this is just left, right, up, down. And then what we do is we iterate through the results of this query. And I'm not going to go into the O notation for these particular for iterating through queries. That's all in Bevy. We can cover that at a different time. But what we are going to do is we're going to iterate through every return, because the assumption is that every item in that query is going to be a unique entity which contains a move action and a location component on it. Does that make? I hope that makes sense. Because now that we know the tile map layers, and we have an idea of where they are, um, we want to check on each of the entities, see where they're at, see where they want to move, and compare it against the tile map layers to see which area they want to. Okay. So what that means is we're gonna look at our current location. This is the getting our current vector 2i, and this is a Godot specific vector because we're messing with the Godot world. We're gonna get that out of the location. We're gonna convert it. Some conversion might need to happen eventually. Anyways, we put in the vector 2i. I'm probably going to update this to do vector 2i. I'll explain why in a minute. And then we want to basically build a list of all the valid valid positions based on this offset um, for this candidate. And we basically are going to iterate through this list and say, oh, hey, given this particular candidate, for each of these potential moves that I can do, can you tell me if this move is valid or not? Now, there's going to be a more efficient way to do this. There has to be a more efficient way to do this. I am not doing this yet, but I'm trying to use this as a demonstration tool to show you that, hey, this is how kind of we'd end up going about it. So we would build a list of all the potential moves. We would go through each of um, the tile map layers with those moves, right? Um, and we're going to check to see if the cell has a navigation layer in that coordinate. So we pass it in a layer, we pass it in a coordinate, and we say, hey, if there's a navigation layer here, we're not caring about shapes or anything. We're going to say, okay, go ahead and push this into a valid position. And we're going to say, okay, this is a valid move. They could move here if they wanted to, and then we're going to call continue. This nomenclature here is how we name loops. Because if I called continue in here without naming this loop, there's potential that if I do this incorrectly, it would actually call continue on the outer for loop, which is not what we want. We only want to continue the inner for loop until that's done. So the easiest way to do that is to name your for loops, and then you can reference that name when you call continue. That's a very that happens in other languages, but this is very Rust specific. And then I'm just printing those out at the end. If you look at the cell that has navigation helper function, we are taking tile data, which there's another helper function. We're basically taking a tile map layer. We're calling tile map layer, which has a function on it called get cell tile data, which just tells us all about the tile at a given coordinate, right? And for that given tile data, we go through and check, is there any navigation layers? All right. Is there any nav layer? And If there's a navigation layer, okay, is there a navigation polygon? Because there could be a nav layer and there could be no navigation polygon, meaning that we haven't actually painted that tile with the nav layer or with information saying that, hey, this can be navigated to. So basically, we're saying, hey, we got to check to see on each of the nav layers if they exist, and really we could do something here that just basically says, okay, check to see if the nav layer easement exists. Again, we're not doing this very efficiently. That's okay. I want to show you how this works. And we're going to go through and say, hey, okay, if there is a navigation layer here, check to see if there's a polygon. If there's navigation polygon and it's not nil, we're going to go ahead and return true, which means we have navigation in that cell. And again, that comes back to here. And all we're checking to see, okay, there's navigation in that cell. We can move to that cell. Go ahead and push it into our valid loops and continue. That's it. I mean, that's kind of a basic system right now. And again, that's just one aspect of pathfinding to check for a valid component. If I was going to use a pathfinding algorithm to where it's a little more prescient or omniscient, not prescient, omniscient as to where it can and can't move, I would probably build a recursive setup on the cell check because we still want the cell check. But whatever's trying to build a route between the player and the destination would need to do something similar. It would need to check each of those tiles to see if it has navigation layer in its given route and move on from there. There's a lot there. Again, I think the biggest objective of this video is to talk about how in Bevy, in this particular case, we can read Godot, get information from Godot, and manipulate Godot. We'll do that later in order to make presentation decisions, so that I do not have to maintain this world in Bevy. What I do have to maintain is probably a list of locations of each of the items and objects that are in there. I might have to iterate when I first start the map through the tile map to spawn. If I put an object on here or object information, I will probably need to go through and make an entity in Bevy for it. But that we can iterate and manipulate Godot through Bevy, and it should be that one way. We can read from Godot, but Godot's code cannot interact with Bevy. But Bevy can push, can read, can push, can read, can manipulate. It can do everything from its side, and that's what we have to do in this particular case. So I talked for a little bit longer than I even anticipated. Really appreciate you. If you've looked at this channel, jumped on, feel free to be vocal in what you want to hear, what you want to see. More than happy to iterate with you. So have a wonderful rest of your day. I'll probably see you all again tonight. Thank you.